Welcome to this course on project and production management. In this introductory lecture, I shall try to give you an overview of the kinds of problems that you face in projects and in production management. The first thing that you have to realize is that there is a close relationship and also a dissimilarity between the terms project and production. I think you are all familiar with the notion of a project. Basically, a project is something that converts an idea, a design or a plan into some concrete entity. You, during the course of your undergraduate studies here at IIT Delhi, have done a number of mini projects, a number of other projects. So you find that they all fit into this definition. And to take some other examples of projects, for instance, construction of a factory is a project. Construction of a new building or a new institute is also a project. Construction of a new highway or a set of highways that our government is contemplating to connect the country with is also an example of projects. Construction of a prototype of a project or a prototype of a product is also essentially a project. So these are all examples of projects, and we have, on the contrary, examples of production of products like a factory producing cars or other kinds of service industries where different kinds of services are being given. An example could be a hospital, for instance, or a post office and all that. So what is the essential difference then between a project and a production in the usual sense of the term? Both of them involve some kind of conversion of raw materials into finished goods. But the difference is essentially in terms of the frequency with which we generally undertake these activities. For instance, a project is supposed to be a one-time entity. You do it once. I have to build a factory, so I build a factory once. Maruti Udyog builds its factory just once, and once the factory is built, car after car is being produced in that same factory. So when it comes to repetitive activities, it belongs to the domain of production, and when it comes to producing the thing for the first time or doing it only once, it's a case of a project. However, I think it would be interesting to see how projects and production are really related. Let's look at some examples. We were talking about the automobile factory. Setting up the automobile factory is a project, but producing automobiles from the factory once set up is an example of production. Building a house is a project. Operating the household and living in the house is a production activity. Constructing a hospital is a project. Treating patients in the hospital and running the hospital in the usual routine is actually production. Conceiving a new product is a project, and manufacturing the product and trying to get returns out of that particular product is the manufacture or the production activity. Similarly, developing a prototype of a new product is a project. This could be developing a new product of any kind, and then producing multiples or trying to commercialize it is the activity of production. So essentially, a product is like going from one stage to another, taking you from one current state in which you are to a more desirable state in which you are, and generally this is done only once. And once this has been done, you reap the benefits of this particular activity and keep on repetitively producing or trying to make use of this particular activity from the project which has been set up in that sense of the term. So this distinction between projects and production is useful, because the nature of the decisions involved in projects and in production are totally different. In real life, when you are trying to manage a factory, for instance, what really happens is that projects and production are intimately interwoven together. Projects, for instance, would involve in starting the production and solving problems relating to operation, maintenance, housekeeping, and subsequently marketing, distribution, quality, and so on. So there could be projects of this nature. But the point really is that even in a production environment, if you join a routine production activity, as long as the production is smooth, you are going on as per you following the usual norms of production. Whenever you typically face a problem, the problem could be, for instance, if the Maruti car, they hear lot of customer complaints about the engine or about the fuel, what would they have to do? They would have to initiate a project within the factory to look after those complaints, and once that project is over, the changes would be institutionalized within the production system. So it is with this understanding we would see that projects and production are generally a mixed package in real life. It is more like the palau which you eat, rice and the peas intimately linked together, and you eat both of them together. Similarly, as a production engineer, when you join a company, you would be doing routine production, and you would also have opportunities to do different kinds of projects in that sense. So I think this particular understanding has to be there. Now, specifically in today's lecture, some of the issues that we are going to discuss are, we have already talked about, for instance, the pervasiveness of projects in production. We know that organizations these days are becoming much more complex, and as a increase in the complexity of organizations, there are considerable problems in both managing projects and production. Another important thing to realize is the distinction between products and services. In fact, this course could be called production planning and control. It could as well be called operations planning and control. However, when we use the term operations planning and control, we are emphasizing the fact that we are talking not only about production of goods, but also about production of services. And since similar principles are applicable to the management of both kinds of activities, we talk about all these things together. And however, when you are talking about services, there are some special problems which you can talk about a little later. Then we will talk about the issue of value addition which takes place in operations. The basic purpose of the production activity in a factory is to add value to the raw materials, so that the final product fetches you more money as compared to what your raw materials were. Otherwise, nobody would be in business. Okay. So production systems have to be designed specifically with this in mind, and you have to look at how the process of value addition can take place and how it can be maximized or optimized to a very large extent. This is one of the major problems of design of a production system. Then we will also talk about a generalized model of production to give you a basic idea about how production really takes place and what are the major parameters involved in production. Because if a production manager has to manage his factory, he must be aware of what exactly he has to do, what are the controls, and how can he control the entire production system. And then after this generalized model of production, we will talk about some performance indicators of a production system. Performance indicators are important because they tell you the direction in which you are going and whether you are going in the right direction or not. So, we talk about productivity, total productivity and factor productivity, and how these other performance measures that can be there which can help us evaluate whether a particular production system is healthy or not. It is very much like saying that if you want to find out whether an individual is healthy, you have identified a number of performance parameters, right? You measure his temperature, you measure his blood pressure, you measure his sugar count and so on and so forth. These are individual performance parameters, and for a normal healthy human being you would expect them to lie within certain limits. Similarly, in a production system you should know exactly what are the kinds of performance parameters or indicators and in what ranges they should lie. Then we will briefly talk about some of the kinds of production systems that are there. You have various kinds of production systems. You can have job shops, batch manufacturing, mass manufacture, cellular manufacturing systems and so on. They have different characteristics. So, the job of a production manager is to maybe choose the right kind of system for a particular application. And finally, a very important thing is the key decisions in the life cycle of a production system. Any production system has a life cycle, which means that you start from a certain you start from the stage of design of the system and you go on through the operation till finally the system has to be totally discarded. So, during these various stages different kinds of issues typically crop up. So, we will talk about these issues. These are managerial issues. What does a manager have to do to run his production system efficiently at different stages of his life, and we will talk about these. So, this basically gives you a capsule summary of what we are going to be talking about in the remaining part of this particular lecture. It is best to begin with the aim of a production system. After all, what is the objective of production? There are so many ways of looking at production, but for our purposes it would be appropriate to say that the aim of production is to provide goods and services for mankind in the right quantities, at the appropriate place, at the desired time, with the required quality and at a reasonable cost. So, really speaking, whenever you are talking of a production system, you are talking about getting right quantities at the right place at the right time and of the right quality and at the right cost, the minimum possible cost. So, in order to achieve this, let us see what exactly a production manager would typically do. So, let us first look at a nature of the production system. Basically, you could say that a production system is could be viewed at a very general level by saying that we have inputs in the system, and these inputs will be provided to the black box here, and these, after the black box performs its operations, you would get certain outputs from the system. So, the simplest way of looking at production activity is to say that it is essentially an input output system in which you have a black box which carries out the relevant transformations that you may need. However, this is the most elementary way of looking at the production system. What we may now do is, we might say for instance that these we can categorize these inputs and outputs. For instance, it is not a single input that you are dealing with in a production system. There are a variety of inputs that you are dealing with. Typically, these inputs are in the nature of manpower. You have manpower, no matter whether you are talking about manufacturing cars or whether you are talking about a textile factory or whether you are talking about anything, you will have to manage these kinds of inputs: manpower, machines, materials, money, information, energy typically, and many more inputs typically. And all these inputs would actually be utilized within the activity of transformation, and you would typically get essentially two kinds of outputs from the system. One is the set of what we can call desirable outputs from the system, which is what you design to or you expected the system to give you. There would, however, always be undesirable outputs from the system, like scrap, fumes, pollution, etc. You never wanted them, but they came because your technology was such, your raw materials was maybe defective or whatever it was, and things like that. So really speaking, in this context, we have to see that the objective of the whole exercise is to maximize the production of desirable goods by utilizing these inputs in some particular manner, and that's exactly what we are trying to do. Notice that these inputs are very important, you know. For instance, each of these inputs leads to a major academic discipline. Managing men is you have a discipline called manpower development or human resource development. As a whole discipline deals with this. Management of machines, basically you can say machine management problems in that sense. Materials management is another area, a complete area which deals with management of this. Management of money, financial management in that sense. So at the whole discipline behind each of these individual informations, management information systems, there is designing appropriate kinds of management information, managing energy, and so on. So all these inputs are important, and the very fact that we have whole disciplines associated with each of these major inputs shows how important they are really in terms of trying to we must therefore try to utilize them properly in getting our production from this particular system. Let us see, we are gradually adding an element in the manufacturing scenario and trying to generalize our model. They started with a simple input output model, but now we have characterized the inputs, we have characterized the outputs, and the other element that we have added at this particular diagram is the notion of feedback. This is something extremely important in any production system, and namely in all cases what happens really is that this feedback is taken from your customers, primarily from your customers or other people you encounter on the way. That means distributors, retailers, customers, all these kinds of people, and they probably give you some kind of feedback on your product, on the packaging, on the performance of the product, and so on. And when this information comes, the impact of this information in the manufacturing shop would be in terms of suitably modifying your inputs, choosing better materials, choosing better packaging for packing your parts and things like that. So this feedback is something important because it tends to keep on constantly improving the production system in that sense of the term. And so we have here these kinds of things about the nature of the production system. We now superimpose, you find that there is this element, a circular element which I have imposed here on top of this model, and this particular envelope actually shows the environment, and the environment has different components. It is the social environment that you could be talking about, it could be the economic environment you could be talking about, or it could be the political environment that you could be talking about. And the important thing to note here is that the entire production system is, as it were, floating in an environment, and this environment lends both a dynamic flavor and an element of uncertainty to it. So the whole thing becomes dynamic, it's moving. Today the government says something on prices of a certain type of raw material, right? So you are happy. Tomorrow the government says something else about the prices of a different kind of raw material, and you are sad as a manufacturer in that sense. So this will constantly keep on happening. Similarly, there could be a lot of social pressure. Social pressure could affect the performance of the system. Social pressure could be, for instance, yesterday you must have read the news about Coca-Cola and Pepsi-Cola being unfit for drinking because of pesticides, harmful pesticides and other kinds of chemicals which are there in the product. Now that has led to a social pressure. Housewives, our Prime Minister, not only the Prime Minister but also our Health Minister Sushma Swaraj has issued a statement that no household should drink these products, things of this kind. So what has happened really is that a social pressure can affect considerably a lot of things. In this case it will affect the demand for the product, and therefore the management of this production system is pretty tricky in the sense that the production manager has to look after these various factors. I mean, it's very much like Pepsi giving a statement today saying that number one, CSE was not is not equipped or does not have the appropriate license to conduct such tests. So you will find that these kinds of things, legal battles, would also be a part of a production system when these environmental factors impinge upon the performance of the production system in that sense. There could be a lot of political interference which could lead to the performance of the, I mean, a certain politician might be interested in promoting some particular product or some particular manufacturer, and therefore he would try to influence the government maybe to bring out legislation to that effect, and this would have again the effect of basically influencing the performance of the production system. Now this model we can call as a generalized model of the production system, because if nothing else it tries to at least tell us about how what kinds of pressures and pulls, what kinds of situations the project manager and the production manager will have to face to run his organization. So you can see all the major functions here. He has to manage his inputs. That means he has to do proper vendor ratings, proper vendor development, and get individual products for his factory. He has to make sure that these are actually transformed properly within the factory, so there are problems of managing the factory within the factory. That's this particular box which we haven't talked about yet. There is a constant change being brought about by the feedback, and of course the entire environment which is trying to. So it's basically, you can say jocularly that a management of a production system is not an easy task. It's not easy because it is dynamic also and uncertain also. So it's like riding a horse to some extent. A horse is moving up and down as you go, galloping horse. So there is an element of dynamism there, you are dynamically moving there, and there is always a risk that if your terrain is bad you could probably fall down and injure your legs or whatever. So that is the element of uncertainty which is there. And another thing that which comes out is that a strategy which is followed today might not necessarily work out after 2 years or after 5 years. Why? Because these factors would have changed, other factors would have changed, and so on. So you cannot really program your operations for this particular production system in that context. So, I think this would give you some idea, this we can call a generalized model of a production system, of how the problems of management of a production system are really not trivial problems, because you have to manage so many things. Let us now talk about what happens within the box. That is the area of the black box, which is transformations. What happens within the area of transformations? The important thing that happens there is value addition. That is the important thing which happens. It does not matter whether you have a machine from Sweden and another machine from Holland and another machine from Ludhiana, all juxtaposed together. The purpose of that system which is designed is actually to add value to the products. That is the whole thing. So, basically operations is the process of changing inputs into outputs and thereby adding value to some entity. This constitutes the primary function of virtually every organization. We must not lose sight of this fact, and basically how we add value to the organization depends upon the structure and the type of management system that is going on. So, we should be careful about that particular thing. Then we could be looking at this value addition. So, we recognize the fact that value has to be added, but the question is, how does this value addition take place? What are the typical things which happen in the black box so that value addition can take place? Well, conventionally they say that typically 4 types of things happen within the factory. The first thing that is going on is you are altering something. What is it that you are altering? You are altering the physical product. So, all machining operations, all welding operations, everything that you do in manufacturing, for instance, is basically concerned with altering the shape of a particular product. So, it could be not just the shape, it could be altering the physical properties, altering the structure, the molecular structure, so that you have more strength, things of this nature. So, altering means that you are carrying out essentially these operations where you are either doing metal cutting, or you are doing metal forming, or you are doing grinding, or you are doing heat treatment, or you are doing, those are the basic physical alterations which take place within the factory. Then alteration could also be sensual. I would leave that for you for the time being to imagine what kind of sensual transformations could be brought about in a input output system. And the alteration could also be psychological, bring about a psychological transformation within the individual, right. A typical example is, you take a book is a production system, you read it, you are in the transformation box. What happens to you? It transforms you psychologically, in that sense, if the book is powerful enough. If the book is all trash, it transforms you in another way. That could be another possibility, but it does transform you. Okay, there is a psychological transformation involved. The other activity which is fundamental to all manufacturing is transportation. This could be transportation of raw materials within the factory, or it could be transportation of finished goods from the factory's finished goods store to where to your retailers and the final customers, or it could be transportation of raw materials from your vendor sites to the factory. Essentially, transportation is a very important exercise. If you are not able to transport properly, you are not able to actually improve the value. Some raw material lying in a mine is valued at something, but the moment it becomes in a factory producing iron ore, iron say, then it becomes useful there. So, the utility of the raw material changes after it is transported. So transportation is something which ensures that you bring the material to the right place, and the value increases as a consequence. Storage. When you talk about storage, how are we increasing the value by storage? In the context of a factory, if you produce something and let us say you are not able to sell something immediately in that particular month, you would typically have an inventory of finished goods, and you will utilize this inventory maybe in the next period or the next period when the demand becomes normal or something of that kind. So storage is inspect, and inspection is a typically very important aspect when you are talking about addition of value, because this is the stage where you are checking whether what you have produced is as per your specifications or not, and that is basically what quality is all about. So you have to talk about these. So essentially speaking, when we are talking about value addition within the factory, we are essentially talking about these various things which have to be improved in terms of the value addition. Here is now a look at the kinds of transformations which might take place within the box, within the input output box. So we have said that there could be physical transformation as happens in manufacturing. I think this is obvious, because we have already given examples of how basically you start with the steel sheets and convert it into a car. Ultimately you are changing shapes, right? And in location kinds of transformation, what you are doing is in transportation, what is happening is the kind of transformation involved is you are changing the state of the material from location A to location B. So essentially transportation is nothing but a locational transformation. When you are doing retailing, purpose where a retail shop which stocks items of different kinds, what is it doing? It is the kind of transformation it is doing is merely exchange. In warehousing, the kind of exchange that you are doing is basically storage. You are storing, that means when you are talking about the whole operation of any warehousing company, what it does is it stores a material at time 1 and produces the same material at time 2. That is what happens to your wheat. You get wheat, it is stored 1 year ago and you get it in the next year. So that is the kind of transformation which goes on in warehousing. So although a warehouse does not have any complicated machines or those kinds of operations involved, but it is performing this kind of transformation. Hospitals, the kind of transformation which goes on within a hospital is physiological. You can go to a hospital with a broken leg and come out with a leg which is hopefully working, or you go with broken knees and come with new knees, like many people including our Prime Minister, for instance. So that's it's a physiological transformation. And then in reading, the transformation is essentially attitudinal. What changes when you are reading? It is your attitude which changes. And in entertainment industry, I mean as in entertainment, the transformation is essentially informational. Right? I mean in entertainment industry is, for instance, you go to a cinema theater, you go in as unentertained man, and when you come out you are an entertained man, hopefully, depending on the kind of movie you see or whatever, in that sense, right? So that is the kind of transformation which is going on there. So I think these are the variety of transformations that we can talk about. So now we have seen the basic model of a production system and seen the various entities involved within the production system. Let us now try to define some gross measures of performance of a production system. Commonly used measures are production, you say for instance that my plant can produce 300 cars per month, okay. So that is your output. So you can measure the total production in terms of output per unit time. So that's how you measure production. Or you can measure productivity in terms of output to input ratio, because the total output doesn't give you an idea of how much you actually put in to get those cars. So it's better to talk about output per unit input in a given time. So this is what we call productivity. Then you might talk about an efficiency. Now efficiency is a it could be defined as actual performance to target performance. You might say for instance, if an actual ideal operator is supposed to produce 59 pieces a day, and that is what we expect from him, and if he produces only 50, then 50 divided by 59 could be taken as a measure of the efficiency of the operator. So notice that intrinsic in this definition of efficiency is the notion of the target value, and the target value could be defined subjectively, right. That's an important thing. Effectiveness. What do you mean by effectiveness, and how does it compare with efficiency? Basically we define effectiveness as the capacity to achieve a desired goal. That is effectiveness. So can you give me an instance, for instance, where we might have a poor effectiveness but a high efficiency, or vice versa? You see, what can possibly happen is that take one of the programs. The government has had so many programs, Garibi Hatao was a program, for instance, the objective of which was to remove poverty, okay. So a lot of money was spent in terms of initiating a number of projects for various things. Now if you review this project after, let us say, 5-10 years, what do you feel? Has this project done its job of removing poverty from the country? No. So we can clearly say that the effectiveness of these procedures was not high, was not good. On the contrary, in a particular procedure, in a particular problem, the government may have decided certain types of procedures, like give every month 5,000 rupees to such and such people. So what could have happened is that in this entire thing, the government could have executed this particular aspect very methodically over the 5 years. So it had to distribute, let us say, 5,000 rupees every year. वो दे दिया, देते गए, देते गए, देते गए. Now once that happens, what would be, so the efficiency of operation of the person or the bureaucrat who is disbursing this money is very good, because he has been dispersing this money and it has been going to whatever use, but the overall effectiveness of the project is not good. So really speaking, it's important. Normally we would take effectiveness to be a major criterion and efficiency to be a lower level criterion. Yes.
So there might be a difference between efficiency and effectiveness based on the relevancy of the target. Like for example, if you are producing something 100% literacy, but over time if that target loses its relevancy, the program is efficient but it's not effective because it doesn't achieve your goal.
Yeah, what you're saying is very true, because what can happen is, one, how do we define efficiency is actual divided by target in that sense. So one thing could be that the target itself is slipping. So there could be, in that sense there could be a problem with the definition of efficiency. So similarly in terms of effectiveness, you have to actually, effectiveness has to be measured with reference to the achievement of the overall goal of the organization. So very right in that sense. And then finally another important measure of performance is flexibility, and basically flexibility means the capacity to respond to changes both internal and external. If you are flexible, then you can respond to changes. And these days flexibility is a very important requirement. Why is it an important requirement today?
Because it's a dynamic world.
It's a dynamic world. Yes, it is a dynamic world. So what does that mean? It means, for instance, that you have a customer today who wants a certain kind of output from you. Maybe tomorrow he wants double the output from you, and maybe he wants a different kind of output from you. So unless you are able to respond to these changes, you would not be able to survive. So flexibility is a key thing, and that is one reason these days there is a lot of emphasis on flexible manufacturing. Flexible manufacturing in the sense that you should be able to produce what the customer wants using the same kind of materials by organizing your production machines and workforce appropriately. If you can develop this kind of thing, then you remain healthy, isn't it? To give you an example, for instance, even in from the realm of health, if you want to remain healthy, you do yoga. What is yoga? The purpose of yoga is essentially to maintain this kind of flexibility in your limbs and so on, really speaking. So even in the human context, for instance, flexibility is a very important aspect, and if you are not flexible, if you cannot bend, then you break, and when you break, you are through. So some similar concept actually applies within this context of flexible manufacturing systems. Apart from looking at those gross measures of performance of a production system, let's try to look at some of the economic measures of performance. And when we talk about these economic measures of performance, we can talk about investment. This is a major economic measure of performance. The initial investment and the phased investment that you have to make for setting up a factory or buying a machine or whatever. The profit that you get from your venture, both gross and net after taxes profit, the revenue, the turnover, the net present value, the benefit to cost ratio, the internal rate of return, and the payback period. Now I am quite sure that you are familiar with many of these financial terms and how to perform these computations for a given set of cash flows for a given thing. So what we are simply trying to say is that since the economic performance of the production system is important, basically this economic performance is measured in terms of these various parameters, and they become important to finally identify whether the proposal that we are talking about or the actual production system is sound on the financial front or not. Let us now look at some of the major challenges in production. What are some of the major challenges in production? One of the key challenges that is facing modern manufacturing is competition, central. And this competition means essentially that there are now more producers and the customers have become more demanding. Both the things have happened. The customer has become more demanding, he wants better quality, better delivery times and lower costs like that, and he can afford to do this because now there are more producers. So these are the two major things which have happened here as far as the competition is concerned. And what are the various ways that manufacturers can adopt to deal with this situation? They can deal with this particular challenge in a variety of ways. they can deal with it by controlling the price, by bringing down the price. That's one of the things. But obviously there is a limit to which the price can be brought down, isn't it? So the question really is that you should be able to find out the level to which you can reduce the price. And if there are, let us say, take an example, if there are a number of manufacturers, everyone says I cannot bring down the price because they might be buying their materials from the same sources and things, but one particular manufacturer would still be able to give you a lower price. How would he arrange this? He would arrange this simply by managing his own costs appropriately. If you can organize your own costs, make your internal system more efficient, then you can offer a better price to the customer. So this is how you can look after your price. Of course, quality is another aspect where you are giving essentially what the customer is asking for. Another thing which is happening is that lead times have reduced, and they have reduced considerably. To give you an example from personal experience, for instance, the experience of Boeing about 6-7 years ago was that if a company, if an airline placed an order for an aircraft with Boeing, they would typically take about 2.5 to 3 years to process that order. That is to make the aircraft. Each aircraft would have to be uniquely made, for the customer. Now the situation is that they have brought this lead time down from 2.5-3 years to something like 1 year, 2-3 months. Their target was to bring it to within less than a year for the manufacture of an aircraft. So this is again an application of this kind of pressure which is there, where lead times are reducing. And in the manufacture of aircraft there are not many suppliers. Generally there are only 2 suppliers in the world, right? There is another thing that is happening is that the customer can want greater variety. So you have to organize your production again, be more flexible essentially. And another thing that the manufacturer has to do is to provide customer satisfaction. How does a manufacturer provide customer satisfaction? What can he do to provide customer satisfaction? One thing that he can do is to provide good quality so that the customer doesn't have complaints. But the second thing he can also do is to provide good after sales service. It should not happen, as sometimes happens in many of our Indian products, that you buy something and the second day the electrical system goes out of order and you have no means of contacting the original manufacturer, although you might even have a warranty with him. So really speaking, customer satisfaction would involve that the customer should be able to contact and should be able to get his job done from the manufacturer as early as possible, and hopefully it should be so organized that the need for this should not arise. That is another thing. So customer satisfaction is really important.
So don't you think that increasing the quality will also increase the price? Okay. High quality at a low price, isn't it impossible to have high
Yeah.
quality?
What our friend is saying here is that wouldn't an increase in quality lead to an increase in price? It may and it may not, but not in the long run. What may happen, for instance, is that when you are providing quality, that means you have probably given him you have provided some kind of quality. The additional costs are generally much more than offset by the increased demand for that product. That's what he's saying. And this is in fact when Crosby said quality is free. This is what he means by saying that quality is free. That is, by providing quality, you have actually increased your sales to such an extent as it is that you have more than recovered the cost of that particular product. That is the idea, and that is what you should do. You should try to enhance your market, in that sense of the term. So these are some of the major challenges, and you will find that most of the research in production management actually hinges on how to deal with this, or 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 how to deal with this. So essentially these are the issues which we talk about in this. Another major development which has taken place in the context of production systems is that originally the focus was only on transformation process and the input output from the transformation process. It has now been recognized that the transformation process is not operating in isolation. There are a large number of vendors who are actually supplying materials to these so they are actually also like limbs of the manufacturing organization. And similarly there could be a number of warehouses where you are stocking these items, and from these warehouses you would be shipping your product to different retailers from where the customer is actually taking the product. So the idea has been that if you want to make the system more efficient, rather than looking at the manufacturing process itself, you should look at this entire chain. They call it the supply chain. So this has been the reason why there is such a lot of emphasis today on supply chain management, because why it is important is that if there is a blockage somewhere in any of these systems, it will lead to the failure of the whole system. It's like saying that whether you have a blockage in the heart, or a blockage in the brain, or a blockage somewhere else in your system, it can lead to a total catastrophe, and this is what is really happening. So this is what has prompted researchers to basically look at the supply chain, and the basic idea here is that by looking at the supply chain, you will try to identify the bottleneck operations and try to improve the bottlenecks, and then try to run the system as a whole. Okay. We were talking about the difference between production organizations and service organizations, production versus service systems, right. So here are some of the features of service organizations which make the management of service organizations more complicated. So these features of service organizations are that there is greater customer participation, and this is a very important aspect, right. For instance, by customer participation I mean that if you go to a hospital with a broken leg, you are a part of the operations. You have to go to the drilling machine, you have to go to the doctor, you have to do this. So you have to flow within the organization. But if I am the buyer of a Maruti car, I don't have to go to the Maruti factory and flow with the where the gearbox is being made and how the engine is being assembled and things like that. I just get the car, right. So because of that, there are when you are planning service organizations, you have to make sure that you have to plan for customers who are participating in the process. Another important thing is that the services cannot be inventoried. Service capacity time is also time perishable. I mean, if you miss the time, you miss it. A doctor's clinic, if he is waiting idle, he cannot prepare some hypothetical patients like inventories in a car and do with that operation. The customer here will govern the location, and generally these things are labor intensive, or they are intangible nature of service. That means the kind of service that is provided to different patients would vary from patient to patient. This does not happen. One Maruti 800 does not receive a different treatment from another Maruti 800, whereas a person with a fracture in the leg receives a different treatment from a person who has a fracture in the arm, in that sense. And so broadly speaking, the whole process of operations management can be defined as the performance of managerial activities in selecting, designing, operating, controlling, updating production systems. So, this could be taken as a formal definition of operations management. I think with this we would like to conclude. So, I will quickly summarize what we have tried to do in today's lecture. We have essentially tried to look at the various in this particular lecture we have tried to look at the distinction between projects and production systems essentially, and then we have looked at a generalized model of a production system, and we have looked at the various aspects of a production system and tried to define the role of operations management. In the next lecture we shall be concentrating on the life cycle of a production system. That means we will try to talk about the major problems of design and operation which occur in a production system and what kinds of managerial decisions are involved in that context.